I'll give you the definition that I have my medium. I can see this one. The light ray that is coming, the light ray. You can see the light ray coming. That light ray, we call it incident ray. We call it the incident ray. Now listen, I want to bring out something here. As human, what we'll be expecting is that this ray of light that is coming straight is supposed to be going like this. That is our expectation. But unfortunately, because the medium has changed, the light ray also will change direction. So definitely you'll now be seeing something like this. So this is my refracted ray. This is my refracted ray. I get my language now. And this is normal. Everybody knows this one as normal. Everybody knows this one as normal. So leaving that side, what will be the next thing? This is the ray. This is the refracted ray. This is medium 1, medium 2. I'll still talk about this one later. Where you can experience this type of thing. Most of you have been to your pool, swimming pool. You will look at, when you are at your swimming pool, what do you see? You see, what do you call it? Not even reflection you are seeing. You see the bottom of the pool closer to you. But when you enter that pool, what do you see? When you feel that the thing is deeper than what you are seeing. That is, we have something called real depth. And we have something called apparent depth. Am I communicating right now? So that's talking about refraction. Another way we can experience refraction. Now, let's start. Like I said, refraction of light, you can see the way diagram. Now I want us to see what I'm referring to as refraction. I want to explain refraction in many ways to you. I want to pour water inside this water, and I will put pencil inside, and you see what is on the board. Looking at this, now this is water, this is pencil. Now look at this pencil. Look at this pencil at the top. Look at the pencil at the bottom. The pencil at the top, the pencil at the bottom. What do you observe?
It's not straight.
You will see that it's not straight. That is what. Listen now. We are seeing something being displayed. I'm seeing something like this, but the real position of this pencil is here. I get what I mean now. There must be a distance between this one. We call it this position that we are seeing. We call it apparent depth. Why we call it apparent? Because that's what is displayed to us, and that's what is deceiving us. And that's why you say, this pool is not deep. Let me enter. When you don't enter, you're like, come and help me, come and save me, because you have already entered. That is apparently deceived. That is something that is deceiving us. Are we there now? But the reposition, that's what about the refracted ray. Am I communicating right now? Alright, now leaving that side, I continue. Listen. Now, I want to bring out something. The angle between the incident ray and normal, we call it angle of incidence. While the angle between refracted ray and normal, we call it angle of refraction. And this is my angle of incidence. This is my angle of incidence, and this is my angle of refraction. Angle of refraction. So in case whenever you are asked what is angle of incidence, just tell them angle of incidence is an angle between incident ray and normal. Anywhere in the world, you give me your full mark. Angle of incidence is the angle between what? The incident ray and normal. And what about angle of refraction? When you talk about the angle of refraction, we are talking about the angle between the what? And what? The refracted ray. Between incident ray and normal, that's angle of incidence. While angle of refraction is between, you can see, between refracted ray and normal. That is angle of refraction. And because of this, we have two major laws guiding this principle. You know, in science, we work with principle. In science, we work with principle. The first, we can see laws. We can see laws of refraction. Laws of refraction. The first law, all of us, let's look up. There is nothing hidden in science. You will see. Even if someone is deceiving you, you will still know. Now look at it. We have a ray. We have this incident ray. This is refracted ray. This is normal. All these three that I mentioned, where they meet at a point. That's the first law. That is, incident ray refracted ray, and normal all meet at the same point. All meet at the same plane. We call it points. You are still right. I repeat, incident ray, refracted ray, and normal all meet at the same point, or all meet at the same plane. Anyone you pick, you are correct. I repeat for the last time. Incident ray, refracted ray, and normal all meet at the same plane, or all meet on the same plane. You are still correct. That's the first law. While the second law, we talk about the angles. You can see the angles. Even from what we can see, you can see this one over this one. The second law is already stated like that. That is what they say. The second law states that the sine, so it says that the ratio of the sine, the ratio of the sine of an angle of incidence, somebody is talking, the ratio of the sine of an angle of incidence to the sine of an angle of refraction is constant. Let me stop at that statement so that it will not be much. Is constant. When you hear the word ratio, something over something, ratio, that is sine I over sine R is equals to what? Constant. This constant, we call it Snell's constant, because this law was stated by a scientist called Snell. So this constant is called Snell's constant. This law, in case you are asked in the exam to state Snell's law, second law of refraction is what we call Snell's law. When you state this law, automatically you will receive 100% reward for that law that you have stated. Snell's law states that the ratio of the sine of an angle of incidence to the sine of an angle of what? Refraction is constant. And this is the constant we are referring to, Snell's constant. For the refraction, as a topic, we call it refractive index. What do I call it? Refractive index. Refractive index. We have up to 5 formulas for refractive index, and I'll give out all the 5 formulas one after the other. That's the first formula I'm releasing right now. The first formula for refractive index, we can call this one refractive. At times you can see in your book saying refractive. You can write it like this. Refract. You can say something like this. This means refractive index from air to glass. A means air, G means glass. That is, if my medium 1, let's say my medium 1 is air, and my medium 2 is glass. This one we have experienced this thing several times. We are still experiencing it now. Look at this one now. Fortunately, I have 3 media here. Our environment is air. This is glass. Inside, I have water. That is, I have 3 materials. Are we there now? But in case there is no water there, I'll be having 2, air and glass. Are we there now? Air and glass. So, no matter how it is written, the same formula system. Are we there? The refractive index of air to glass is sine I over sine R. I'm still saying the same thing. You may see it in your textbook that they are writing it like this. They are saying the same thing. Is that clear to you now? Refractive index from air to glass. That is, the light is traveling from air to the glass. That's the meaning. It's traveling from air to the glass. What about if it is traveling? At times, if you see something like this, if I write something like this, it means it's traveling from glass to air. From glass to air. We'll still talk about this one when we are talking about total internal reflection, when we are talking about critical angle. I will still talk about this thing. I guess we're learning now. But for now, let me stop on this one. And the next thing will now be, how can they ask you a question? You know something about science that you children of that you are missing, that science is so sweet. When you are sound in theory, your practical will just be very sweet. When you are sound in theory, I do tell you, someone like me, it's very rare you see me. I can do most practicals on my bed. What do I mean by my bed? That since I have my formulas, I know the theory. With the theory, I will get the result. You that you are carrying out the experiment, you won't get better results than my own results. Am I coming this right now? So what am I saying? That very sound in your theoretical aspect. A formula has been given that sine I over sine R. Let's assume, listen up. Let's assume in a practical, you have been given. You have known the refractive index of that glass, and you are given a particular angle. So to find the values of R will be very simple. What am I saying? Take an instance now. let's say, look up now. Let's say they are talking about given that the refractive index, given that the refractive index of a glass is 1.5. Is 1.5. If the angle of incidence, everybody let's do it together. If the angle of incidence is 30 degrees, what will be the angle of refraction? 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 That's the question. Like I always say, whenever you are given any question, try to read and interpret. Read through the lines, interpret. You will see it's very simple. You want to try? You said 20. I'll go. Have you solved it? You know you have a sign. You want to go by the sign. You take all this that your forgotten was okay. Or your calculator. Very simple, you interpret. That is, you will say solution. Given, what are given parameters? Can someone speak? What are given parameters? 1.5 stands for what? The refractive index, right? Our refractive index for glass is 1.5. Am I communicating to someone? Am I talking? And what about the 30 stands for what? Our I, right? That is angle of incidence, right? Our I is 30. And we want to find R. The formula is alive. Let us also be active with it. What am I saying? It says we have sine R. Like this year right now, they are going to work on refraction. For any student that is very smart, once the student knows the refractive index of the glass material, the rest is just to fire up. Within 5 minutes, you have done the practical of 1.5 hours per question. Am I complicated or 1 hour per question? It depends on ideas. That is very smart. The sound in your calculative aspect. Alright, now sine I over sine R. What's my I in the question? That is, I have 1.5 equals to sine 30 over sine R. Am I communicating? Yes, mathematician, what's sine 30? Sine 30 for the forgotten, that's 0.5, right? That is 0.5. Are we there together? Over sine R. Am I communicating? Am I communicating right? Okay, now make sine R the subject of formula. Sine R becomes 0.5 over 1.5. Am I speaking your language? You can use your calculator to carry on. 0.5 over 1.5 is what? Press calculator, give me something. Yes, you don't have a calculator with you.
0.3. 3.
Are you sure?
Yes.
You know, if I use one mathematics, it's 5 over 15. That's 1 over what? 1 over 3. That's sine I equals 1 over 3. Or I say, you know, 1 over 3 is 0.4. Yeah, 0.33. Like that. Are you there?
Yes.
Alright, since sine R, mathematicians to find R, you find the sine inverse, right?
Yes.
Sine inverse of 0.3333. Who can help us out with that? Your forgotten is not with him. We can pick up, yes, inverse of sine 0.33. Yes, give me something. Inverse of sine, like the inverse sine of 0.333. Inverse sine. Yes, let me hear from you. Yes, yes. What do you have? Sine, what's that? What's that? What do you have? Just press inverse sine 0.333. Yes, I'm with you. What is it? 19.45. According to you, you said 19.45. That is degree. If I want to approximate, I will say R equals to approximately 19.5 degrees. And that's how I'm done. In the practical, I don't need to touch any experiments. Touching the experiment is like wasting of time. We all know where we belong to. At times, the environment may not be favorable for the practical you are doing. You know, we are talking about refraction. Refraction is under a branch of physics called geometric optics. That's light. You need light. So definitely the light is not bright. You won't get the results. Like this one I put in front of us, because there is a little bit of light ray. If there is no light ray, we won't see clearly. That is, we need. Hello, am I communicating now? We need light to perform experiments in the geometric optics. Am I completing this right now? So I have used that one to explain how question can be asked. And from there I said I'm giving out 5 formulas of refractive index. I'm giving out one right now. That is, this one talks about the relationship between what? Between air and glass for medium 1, medium 2. You may want to wonder how that and we are going to be given prism. Are you telling us prism will be like this? Let me give you the diagram. How you present yourself with this prism. Can I rub this side? Yeah, okay, let me rub this side so that I'll show you how it can, in a real life when you are doing your practical, how you present it. You see it now. Very simple. Very simple. Please don't forget the laws. There is no way you will do refraction experiment that you don't have to state the law. You will state the law. Because it is in science and physics, we follow the principle. Alright, let's assume. Hold on. Okay, let's say I'm drawing my rectangular prism. You know, we have two prisms, we have rectangular, we have triangular. I think I'll show you the last class of the previous one. Now, look up. Here's my prism. Let me label it. You know, we call the topic geometric optics. That is with the diagram. Like your mathematics, you make sure your angles, wherever. A, B. Let me label it. A, B, C, D. Now, look up. The first thing you do, you will be given your white papers. If it is a practical, you have white paper, you have your drawing board, you place your white paper on it, you place your prism on it, you trace it out. Because it's your regular class, that's why I'm not bringing all this apart right now. So you place your prism, you trace it out. This is my tracing out of the prism. I have the 4 vertices and the sides. Can I communicate? Can I continue this? Alright, I have my normal. The first thing you use your ruler, you draw your normal. That normal is what that will help you to know how you can place your is it your protractor, you place it on it so that you know the actual angle you are giving. Alright, so listen. I have normal. Now I pick up my incident ray. You will be given a particular angle. You must be given, they will give you incident angle of incident that you are going to measure. Let's say they have given me 30. Let's have been given 30. So I will measure with my compass with that, so I'll put up everything. I will get my 30. I will measure my 30 degree. That's the angle of incidence. This is my what? Incident ray. This is my incident ray. And also in that practical you will serve 4 pins. 2 for objects, 2 for image. That is, 2 will be placed as object, the remaining 2 will be used to trace what you are saying. But I have told you, the environment we are in the part of the world, Nigeria and the likes, you know, for you to see clearly, you may be struggling. That's one of the fear that makes students to run away from this practical. Fear of, will I see very well, and especially because I'm using glasses. So glass become, you have like 4 glassy material in front of you like that. Everything now be looking like magic. So those are the things that affect or that send away students from all this type of experiment in the examination. Right? Since I've given you the rule like formula, don't throw it away. I'll give you the trick behind it now. I have my incident ray. I have my incident ray. Now again, look up, you are talking. Now the next thing will be now, I will place my pin at these 2 positions. They will tell me maybe it's called, maybe this one is P, this one is Q. I will now pick up my pin. If that's going to be practical, you will be checking at the other side. Let's say I have done that and this is what I experienced. Now, the points where this thing is missing another bandage. Look up now. This is air. This is glass. This is air. Like this thing. If I pour away this water now. If I pour away this water, this is air. This is glass. Inside is air. This is what he's talking about now. So, in that situation, the bandage between this glass and this air, I will draw another normal line. Normal means perpendicular line. Normal. So I've drawn it now. This is my angle of incidence. This is my refraction. Angle of refraction. You will use your protractor to measure that. You measure that one. Once you measure that one, you will know the angle of incidence. But since I have put my formula, I have gotten the answer. And here again, see something. I will bring out something. I know when I have refraction, there's somebody like, what will I have here again? Here we will now be having something called angle of emergency. That because this is emergent ray coming outside. Emergent ray. I have my emergent ray here. I have my emergent ray like that, but it will not take you far. I have my angle of refraction. I have it. So that's going to be presented if I'm using prism. I'm doing it in practical. We are going to carry out practical on it by God's grace next class. You will see, you will be grouped, and likewise, there will be light enough for you to do that. So that is to explain it practical and likewise theory. But when you are going to stand the theory at the beat, practical will just be what? Will just be fun to you. That's just it. To me, I see practical as an avenue for scientists to catch fun and to create, to build up, to give us what we call creativity. That's all. It's not a moment of struggling, or it's not a moment of a body. The moment to bring out something new or to catch fun. Exactly as you know. But if your own practical or experiment you are carrying is becoming a load on you, you will be tired to be a scientist. All right, thank you. So leaving that aside, I've explained this. The next thing I will talk about here for refraction. Now I'm moving forward. What about if I'm using triangular prism? If I'm using this is what we call triangular prism. You can see the triangular in shape. I want to create the second formula now before we close the class. The triangular prism so what will be the formula for the refractive index? Is the same formula, but the formula will not be expanded. But because of time, I will go straight to the point and tell you the meaning before we say bye for today. Before we say bye for today, let me quickly show you how it is. I will not draw because of the time. Alright, now I will just say my refractive index will now be my sin I has now become sine open bracket A plus D over 2. That is angle of the prism, minimum deviation over all this my sin I now. My sin I becomes angle of prism divided by 2. This is the formula. This is the second formula of the refractive index. This is the formula we use for the triangular prism. This one can only be expressed in triangular prism, while the first one will be expressed in rectangular prism. Is that clear now? Rectangular prism. So, and like I said, A, your angle of prism, the D, your minimum deviation. I will stop getting there. So, if truly you have understood what I taught you, let me just give you this one to try. Now, you will try this one, not now. Just try it when you are less busy. So, I'm giving you the refractive index here as 1.5. I'm giving you the refractive index 1.5. I'm giving you my I. Let me see, I have the I values. I said 15, 20. No, my I is very degree. 20, 25, 30, and 35. Next class, we talk about that. Likewise, how you can plot the graph. So, obtain your values of R and by